Hi everybody, welcome back to another video lecture from Mrs. Semino. Today we're going to be talking about how to name and write formulas for compounds. This is actually going to be a series of 4 different videos. In the first video here, I'm going to go ahead and I'll be talking about ionic formulas and writing. In the second video, I'll be talking about polyatomic ions. In the third one, about multivalent ions. And then the fourth one, we'll be talking about molecular naming and formula writing. So we may have discussed this in class already, but this is just kind of a reminder about it. So we need to talk about how can we identify the difference between ionic and molecular compounds. Remember, molecular compounds, they can also be called covalent compounds because they have those covalent bonds in them, but technically they're called molecular compounds, okay? So in order for us to tell the difference here, we need to just be able to look at the chemical formulas. And so ionic compounds are going to be made up of metals and nonmetals. So if you look here, you can see that like sodium is on that left side of the periodic table, so it's a metal. Chlorine is a nonmetal. Iron, of course, is a metal. Oxygen, nonmetal. Calcium, metal. Believe it or not, right, it's in that second column on the periodic table. And then carbonate here is a polyatomic ion, again, nonmetals. And you can see metal, nonmetals again. On the other hand, molecular compounds only have those nonmetals in them. So for example, water and ammonia here, they are hydrogen's a nonmetal. Even though hydrogen is like on this side of the periodic table, right? It's a nonmetal, but it is just over here because it has that one valence electron. So just reminder, hydrogen's a nonmetal because it's a gas. Then we can have ammonia over here. Nitrogen is a nonmetal, it's like over here on the periodic table, and then hydrogen again is over here. Carbon dioxide, right? Carbon's about here, oxygen's like right over here. So again, nonmetals, and then hydrochloric acid, our hydrogen and our chlorine. And in case I forgot to mention it in the last slide, remember we can look at that staircase here, and all the guys on this side are the elements on this side are metals, and then on this side are the nonmetals. So now before we start talking about ionic compounds, we should talk about what an ion is. And again, this might be a review for you, so just kind of hang out for a second. So an ion forms when atoms gain or lose electrons, okay? So down here, here's an example of calcium. Calcium would end up losing 2 electrons. And when it does that, it's going to end up having 2 more protons than electrons. So we'd say it has a 2+ charge. On the other hand, chlorine here has 7 valence electrons, so it would want to gain an electron to have a full valence charge, so we would say that it has a 1- charge. So you've probably seen these before. When we have the element symbol with a little charge, this is an ion, okay? Then we can describe ions a little more specifically. If we called something a cation, it's going to be an atom that has lost electrons, so atoms that lose electrons become positive. Right? And if you're losing an electron, electrons have a negative charge, so that's why you're going to become positive. And then anions over here is an atom that, oops, I'm seeing a typo right here. Sorry, guys. That gain electrons, okay? They're going to gain electrons and become negative ions. And then, again, electrons have a negative charge, so if you're gaining electrons, you would have an overall negative charge. Okay, how do we name ions? So over here, I've got the cations, okay? And then here's just some different cations. And then we can see like this is the hydrogen ion, magnesium ion, aluminum ion. Notice how all of these are ending in ion. So if it's a cation, we're gonna include this word ion to describe that it has a charge. Over here, naming anions, fluoride, oxide, nitride, okay? So you can see it has the different charges. Notice how all of these are ending in IDE. So we would add this IDE suffix to the end of the word, okay? And then that replaces the word ion. So we wouldn't say a nitride ion because "ide" is already implying that we've already made an ion here. Okay, so just as a quick reminder, because we'll see this in a second, if it's a cation, the name stays the same. We're just going to add ion to it. And if it's a negative ion, we're going to add IDE to the end. Okay, so now we're going to get into probably the most difficult part of the this nomenclature, this like formula writing and naming part, and it's writing these ionic formulas, okay? So ionic compounds, remember these are ones that are gonna be metals and nonmetals. They form when we have those oppositely charged ions that are attracted to each other. So on the last slide, we saw we had positive and negative ions. They'd be attracted to each other. And then they're going to form in a ratio of positive and negative ions so that the compound doesn't have a charge. So this is actually sodium chloride. You're probably really familiar with that. So do you see here how this one has a Na, sodium has a 1+ charge, chlorine has a 1- charge. So since those charges are canceling out, we would go ahead and just write NaCl, and then notice there's no charges in the formula here. Here's another example. So this is sodium. This is called a polyatomic ion, and we'll see these a little bit later. But this is just like a group of atoms that are bonded to each other and they have a charge. So 1+, 1-, again, would make our sodium chloride here. So this up here should be in this box, but the idea is that we would see charges in the ions, but we don't see any charges in that final formula that we're writing. Okay, so here's a couple more examples for you how to do this. So let's say we took lithium and fluorine, okay? We'd want to look them up on the periodic table. We'd see lithium has a 1+ charge. We'd see fluorine has a 1- charge. And I kind of just wrote them like this because sometimes kids are confused. Like if it says 1+ here, but we can just write the plus, and so we're assuming that that 1 is there if we wrote the 1+. Down here, if it was more than 1, then we would go ahead and we would say 2- or 2+, whatever it was, okay? So either way, with the 1+ or just the plus by itself is okay. Okay, so getting back to this, if we look at lithium, we can see that it has a 1+ charge. If we look at fluorine, we can see that it has a 1- charge. And so 1+, 1-, they're balancing each other out. And so that would give us lithium fluoride here. And we'll see that in a second. And sometimes for my more math inclined friends, you can see that we would do +1 plus -1, and this would equal 0 or a neutral compound. If we look down here and we had lithium and we had oxygen, again, lithium is going to have a 1- charge or 1+ charge, 1+. Oxygen has a 2- charge. So if we were going to look at these, we would need this 1+ charge plus this 1+ charge plus this 2- charge, and this would equal 0. So let me write this out to be a little bit better. So we'd have a +1 plus a +1 plus a -2, and that gives us 0, excuse me, or you can see that there's no charge here or a neutral compound. But we ended up needing 2 lithiums to balance out the charge on the oxygen. Okay, here's a couple more examples. So calcium, we can see that it's going to have a 2+ charge. And then each fluorine has a 1- charge like we saw before. And I know I kind of wrote this like in like a horizontal way, but I kind of like doing it better like in a vertical way. So let's say I've got calcium, I've got fluorine, I've got a 2+ charge, and I have a 1- charge. So right now I would be +2 and -1. So those charges are not like balancing out, or if you add them up, they're not equaling to 0. So how could I get that to equal up to 0? I could add 2 fluorines here, and now my compound would be CaF, and then 2 of the fluorines because we had 2 here. Now if we look at calcium and oxygen here, okay, look at the 2+, 2-. Are those charges balancing each other out? Yep, they sure are. So I would only need 1 calcium and 1 oxygen, so no subscripts were needed here. Okay, and then we can see we've got calcium and nitrogen here. Calcium, again, is going to have a 2+ charge. Nitrogen would have a 3- charge. And again, I'm going to do this like in a vertical way instead of like this horizontal way here. So if I have calcium, 2+, okay, I'm at +2. And then if I have nitrogen, 3-, I'm at -3. So right now, these charges, they are not balancing each other out. Like if we added them up, they're not adding up to 0. And so in this case, if I added another another calcium, this would make it 4+, still not balancing out, okay? If I added another nitrogen, now that would be -6, right? The 3- plus the other 3- would give me 6-, or -6. So if I add another calcium here, this would now be +6. And now these charges would be +6, -6, so they'd be canceling out. But we needed 3 calciums, 1, 2, 3. So that's why I've got the 3 subscript here, and 2 nitrogens for those to balance out. So go ahead, take a second, use your periodic table, test these out, write the formulas for them, and then pause the video and then come back and look at the answers. Do, 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 do. Okay, so I'm just going to go ahead and work these out for you. So if we had sodium, Okay, if we had sodium with a 1+ charge, and then we have oxygen with a 2- charge, we would go ahead and we would see that this would be 1+, okay, and this would be -2. And it doesn't really matter if you put the plus in the front or not. The idea is we're just like adding up the charges. So obviously here, these charges are not balancing each other out. So if I added another sodium here, this would be +2. Now, do you see how the charges are equal to each other? So that's why we would write the formula Na2, because we needed 2 of them and 1 oxygen. Now, if we had aluminum here, okay, aluminum is going to be a 3+ charge, and then oxygen, 2- again. If we were adding these up, this would be +3, -2. Again, the charges aren't balancing each other out. And so you kind of have to think of like what's the lowest common number that both of these could be multiplied into. So if I added another aluminum here, do you see how that would give me a +6? And then how could I get a +6 on this, on the oxygens? I could add 2 more oxygens, and that would give me -6. And now the 2 charges, if we added them up, they would equal 0, right? Because that would be a -6 there. And so that's how we're coming up with 2 aluminums and 3 oxygens. And then finally, again, we've got aluminum, 3+, nitrogen, 3-. Do you see how these charges are balancing out with each other? Okay, so this would be +3, -3. So we just need 1 of each. So that's why there's no subscripts there, because it's implied that if you're writing the element symbol, that there's at least 1 atom there. So that's why we can just write ALN here. Okay, last topic for this video is how do we name ionic compounds? So just look over here, look at the formulas, look at the names. And then the question here is, what are you noticing about the name of the first element? Sodium, potassium, magnesium, aluminum. I'm hoping you're noticing that this name stays the same. And this is kind of like when we were naming the cations before. It's just that nothing changed about the name, it just stayed the same. But then what do you notice about the name of the second element? Again, chloride, oxide, fluoride, oxide again. Notice we're adding IDE to the end of these, and this is what's indicating that it's a negative ion. Okay, so using the examples on the last slide, go ahead and try writing the names for these. Remember, the first element's name is going to stay the same. The second element's name, you're going to add the IDE to it. In a second, pause the video and then practice these, and then unpause it to come back and check your answers. Okay, so here are the example some more problems that the problems we just did. Is the first element is lithium, so it's just lithium, and the second element's fluorine. Notice how we changed it to fluoride. This is gallium, so gallium's name, and then this is nitrogen, but we call it nitride. This one is strontium. Strontium stays the same. Chlorine, but we call it chloride. And then the last one here is potassium, so that name stays the same. And then this would be sulfur, but notice how we're calling it sulfide. So it's really not that complicated as long as we can remember to add the IDE to the second name. Please write down any questions you have and ask me when we meet next time. Thank you. Bye.